Hi everyone, this is Grania and I'm joined by
Prince,
yeah.
founder of AI Insights, and I'm here together with Garia.
hmm
You want to tell them what we're going to talk about today?
Yes, okay, so we're going to talk about a lot. So the general theme is like new frontiers of AI, and we're discussing three different facets of that. So we're going to discuss AGI, artificial general intelligence, agentic AI, and then neuro-symbolic AI. And then the starting point for this entire discussion is actually very much so not a new frontier, but is back from the 1950s. It's this article that, or research paper, however you want to call it, that was written by a scientist slash mathematician slash many things. He wore a lot of different hats, but his name was Turing. And he's best known probably for cracking the Enigma code in World War II and decoding messages from Germany. And he was like this brilliant mathematician. Like, I think his IQ was like 180 or something. And he produced like so many groundbreaking contributions. And this 1950s paper really set a precedent and then can be connected, and rather is connected to these three different forms of contemporary AI development. So going like straight into AGI. So AGI, artificial general intelligence, is basically a word attempting to describe artificial intelligence forms that are, of a greater intelligence than what we have currently, that can think just as well as humans, if not better. It's a very like ambiguous categorization because it's such a heavily contested field and it's kind of like a shifting goalpost. So there's a lot of different definitions from a lot of different parts of the world, and then just different ways to classify it, different benchmarks. But however, like the classification can be defined a little bit better in distinguishing it from what it is not. So there's also, in contrast, ANI, which is artificial narrow intelligence, and then ASI, which is artificial superintelligence.
Mm-hmm.
And yeah, so how Turing described it though in that 1950s article is, can machines think? And that was like the central question that he sought to answer and kind of how he introduced the article. So what do you think about that?
I think it's generally interesting to talk about Turing because we know him as one of the figures that helped like create AI as it is now. Like he was one of the on the precipice. I mean, it was started by a woman named Lovelace. She like invented the
Yeah,
yeah.
yeah. Turing interacts with her theories in this research article, although he does kind of like, it's not all praise. Yeah.
I mean, scientists are always critical of each other. I mean, in her time, people didn't even like listen to her opinion at all because she was a woman.
Yeah.
So it's interesting to see this dynamic also because I think, yeah, like you said, it was in the 1950s that he wrote this paper,
Mhm.
and I think she came out with stuff like in the 1870s. So there's like a 60, 70 year gap between them also.
Whoa. Yeah. No, that is a six, like, that's a lot of time.
Exactly. I mean, all great things are started by women, but that's just
Yeah, literally like this podcast right now. But yeah, so the central question, can machines think? So I asked you like what do you think of that question, but Turing didn't even really answer that. He said that it was too ambiguous of a question and that instead it could be answered or examined through a thought experiment. And the thought experiment was with figures A, B, and C. He reduced it to like a
hmm
mathematical equation, etc. But kind of the essence of it that is cross-applied today is, can a human tell that it is a machine or not? And there's a few different studies. I'm saying this off the top of my head now, but there was a study in roughly, I think it was like 2005, that people could not determine that it was machine 50% of the time. And then there was a study in 2021 that 70% of the time people could not determine that it was a machine. So by this Turing benchmark, um, it can be approximately said that we are at least closer to achieving this conception of AGI, insofar as humans cannot determine whether it is artificial intelligence or not in controlled studies.
I mean, if you, what you could also look at is, indeed what you talked about, that if humans can detect this kind of thing. I don't
Right.
know if you read the article that was in The Guardian where they checked if the, what do you call it? The declare, what's the American document called? The Declaration of Independence? I don't know if I'm saying it right.
Declaration of Independence.
Declaration of Independence. Oh my God, I can find the English word for it. That
Uh-huh.
it was 90% written by AI.
Oh, yeah, yeah, I remember seeing that. That was funny. That actually made waves in like the academic community because everybody was like using that as defense for their like AI generated content or like alleged AI generated content. Actually, ironically, the leading university in Ireland, their second year class, it was determined that actually, never mind, I'm not going to go down that path, but basically, a lot of universities are publishing some pretty like jarring, there's some jarring findings that like significant percentages of the university classes are yeah being like flagged for AI and etc. It's completely different. Like I don't know, it's unprecedented in a sort of a way, at least like the societal application. Anyway, so moving swiftly forward from that, he presents this thought experiment, and the deduction from it is the test: can a human determine if it's the machine? If it is a machine, and then he kind of explores some reasons as, or he explores like some arguments, including one from Lovelace. But the thing that I found most interesting about the different arguments that he was exploring is he referenced machine inability to access extrasensory perception. Let me know what you think about this. So he was actually of the opinion that telepathy is a real thing, and telekinesis and kind of like these, ambiguous and innate attributes of humans. He was of the opinion that it did exist and that it was a strong argument and it was something that potentially machines could not replicate. I'm actually going to go to my notes on it. I was reading about it today. So do you think that telekinesis exists? Start there. Yeah, telekinesis. Wait, sorry, here are the four categories that he pointed out. Clairvoyance, telepathy, precognition, then psychokinesis, and slash telekinesis. So those are categories of extrasensory perception that he does, subscribe to. And he says that statistically, telepathy exists, and he identifies this argument as strong, and he's unsure if AGI or digital computers would be capable of imitating that. So but the way that I would kind of interpret that is, like telepathy is kind of a more controversial term. I would reduce that to human intuition. So, do you think that there's a form of human intuition that the creation of like an AGI system would be able to replicate?
That's a very good question. I mean, for example, the twin experiments, right, which were conducted by two psychologists to see if twins can think telepathic.
Yeah.
And there were two arguments to the side where one was, okay, they can sense each other. So in the supernatural sense, like they can sense each other so they know what the decision is going to be. But the
Hmm.
other argument was that they were raised in the same environments and conditioned like same clothes, same food, and because they had the same kind of behavior, the way they would think would also be the same. So that was why they were making same kind of decisions when it came to like, do I pick an apple? Do I pick a banana? And they both picked the banana because
Hmm.
they both like banana because they were raised, you should like banana.
Interesting. Yeah, no, that's
By the way,
definitely
that's an
one.
example. I don't know if that there actually was a thing, but it's just to explain the reasoning.
Yeah. But yeah, no, that is really interesting. There are like some aspects of genetics that, I mean, at least for right now, like there's no such thing as like, I guess, absolutes anymore, but appear to be like out of the grasp of machine learning. Have you ever heard of like people like hearing things in their dreams or like predicting the future like through their dreams?
I have heard of it. I've also seen. I also play with tarot card myself because it's interesting
Really?
just to see. Well, it's interesting to see if the predictions that are come out of
Yeah,
it, if they actually come true. It's an
yeah. Has it come
experiment.
true?
It's mostly based on coincidence, in
Yeah.
my opinion.
Okay, one time one of my friends did that for me. I was at like this party and like a girl had it and she was like, "Let me do it for you." And I was like, "Okay." And then she did it and I was like, "Oh girl, like this is completely wrong." And then it was completely wrong, but maybe she was just bad. Anyway, okay, so that's a completely other subject, but the
Yeah,
question of can machines recreate or imitate extrasensory attributes that are, usually kind of inherent to humans?
yeah.
The answer
I
is we
think
don't know, but Turing did identify this in the 90s. He said it was a strong argument. Thought I'd bring it to the floor. Next. So he kind of discussed all these like arguments, like not necessarily against AGI, but like limitations on artificial intelligence, for example, like the fact that it can't replicate like extrasensory, whatever. And then he proceeded to kind of discussing a framework for how AGI could come about. And the way that he phrased this was so like, I don't want to say like dystopian, but very like sci-fi kind of. Like usually when I'm reading like research articles, it's very like numbers, 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 predictions,
Mhm.
statistics. And what he kind of put forward, and this is from the 90s, is that the way that, the way that like knowledge or the way that knowledge is created or like humans are created or how AGI should be created in replication of humans is through three different steps. So number one, the initial stage birth. So we're starting from scratch, initial stage birth. B, education, and then C, other experience, parentheses, non-education. And then he was like, okay, so we have this framework, we have our three steps, and this
Mhm.
is all we need. And from these three steps, we derive two different aspects. There's two different things that we need to program that we can understand from these two steps, and that is we need to program the child, and then we need to program the education process. And that's kind of like a crazy, and the way that he discusses the education process is so fascinating because he literally states, like within the paper, he was like, let's build a robot. Let's build it off of a baby and let's send it to school. It literally says like hopefully the other kids don't make fun of it too much. And I was reading that and I was like, this is crazy. And like very like sci-fi-esque. And he was discussing even like, like the specifics of the robot going to school. He said like, the robot wouldn't need to have eyes, the robot wouldn't need to have legs. Like hopefully the other kids wouldn't be mean to the robot if it didn't have those things. And then he kind of put the stipulation on top of it. Well, it doesn't even matter if he has like the presence of like eyes or this, that, like it
Mhm.
doesn't matter with regards to the education process because as long as there's a metric of communication, it'll be possible to educate. And then he used the example of Helen Keller, in kind of like providing, like a scenario of like how education can be performed under different circumstances. I found that extremely interesting. And then he kind of adds the additional framework that this child, its education would be performed under the punishment reward system,
Mhm.
which we then see reflected in the next form of AI development that we're going to talk about. Punishment reward system, again, he like, kind of extrapolates on that, goes into details. He's discussing, for example, like how the punishment can't be like too extortionate and how we need to have like a non-emotional mechanism of communication for these AGI systems to develop. It's very like interesting conceptual work and just like the way that it's phrased, especially for the 90s, like it is so, almost like rogue to hear like, and then we send the robot to school and hopefully it doesn't get bullied. But yeah, so that's kind of like a very intense like summary, or sorry, very brief summary, reduced, simplified summary of his, initial thoughts on AGI.
The topic of AGI is coming back after the past what's now
Mhm.
past 5 years of AI coming into existence and like going off in a spear, and suddenly everyone having to talk like, okay, what is it actually? What can it do? And actually, what does happen when we create another kind of intelligence that's similar to ours or even greater than our own intelligence? What do we do then? Do they get human rights? Do we not get human rights? I mean, there have been a lot of video games also about this concept. For example, Detroit Becoming Human is a good example.
I've heard about that. I'm not huge on video games, so like I don't know any like the details, but I've definitely heard about that. And anyway, like in reference to that, line of thought, the way that he ends the paper is like with this quote, which I thought was really good. He said, "We can only see a short distance ahead, but we can see plenty that needs to be done," which I think is pretty, it's simple, but there's definitely a message there. Like we can only really like there's so much that could happen in the future, like focusing on like what's happening and trying to like, yeah. Another big area, and like I think it's too much to talk about like in this specific episode, is like AI regulation with regards to like the fact that like we can only see a short distance ahead, but there's so much that needs to be done. I mean, there's so much advancement occurring, and I think that like regulation needs to be accelerated to the same degree that innovation is.
No, exactly, and that it's not just like it adheres to like the regulation of the country, but also bringing in the ethical perspective as well. Like, is it actually right? Like, because one thing it is to look at, okay, does it actually adhere to the law? The other thing, because the law can say like, okay, it's perfectly legal, but then you also have to question, okay, but ethically, is it also allowed, or is this actually going into people's privacy, even though the law might say it's okay? You
Hmm.
also have to look at the ethical side as well.
Yeah, completely. And then another like kind of note on ethics. I just thought it was interesting, like the concept of the way that he described it, like the way that he like kind of compared it to
Mm-hmm.
a child, like a child in school being programmed or educated through like this punishment reward system. It was really interesting, like specifically what he said, like he identified like a hope, which is that there's so little mechanism in a child's brain that like a child's brain can be easily programmed. And like that's an interesting thought to me, like the concept of trying to program a child's brain, and then like the contents of a child's brain, and he uses the word mechanism, like the extent to which that mechanism would be like big or like
Mm-hmm.
substantial or insubstantial. I don't know. Like there's a lot to be considered there.
No, exactly. It's interesting that he did compare it to a child's brain as well, because
Yeah.
I mean, children are, like, I said, can be programmed, but in the sense they are also dependent on their environment as well, like where they're raised and stuff. But a computer program is really something you just put it in there and you just tell it what to do. A child
Yeah.
still has an opinion.
Okay, so on the topic of telling an AI what to do, so the next aspect of what we're going to talk about is agentic AI. And then again, like all of these are going to have contentious definitions, but a prevailing definition is that it's an autonomous system
Hmm.
with little to no human intervention. And the human intervention that is, I don't want to say little to no human intervention, the human intervention takes a different form. And again, like prevailingly autonomous system, and they are also trained. And the reason I find this interesting is because I this concept also is really derived from that one nice paper. They are also trained through the reward slash punishment kind of framework. But yeah, agentic AI is a huge area that people are developing. I had a lot of thoughts on AGI. I have less thoughts on agentic AI. My main thoughts are kind of just like circulating around um the data protection, really like data protection, and then also like kind of like the contortions of how the systems will actually operate. For example, Microsoft has been developing agentic AI. Like I read like a research paper from Microsoft, and they stated that one of their agentic systems actually went haywire and then started issuing a freedom of press notice or something. Basically, like it couldn't complete a command. So then it started doing like something completely random, and then they had to like shut it down from there. And that is concerning, to say the least.
I mean, a lot of people are comparing agentic AI already to AGI because for them it looks like, oh, the thing is like completely thinking on its own. But it does have like, it was trained on how to do these kind of steps beforehand to perform a certain task to completion.
Hmm. I just searched up. I'm trying to see where I found the. We'll put a note actually after we like publish it, and then I'll have the link to like that specific situation that I was talking about with it going haywire. Going.
Yeah, we didn't do I did a previous podcast with someone who's an advisor on the data protection board. I think it's also
Hmm.
good for our viewers to listen to that one if they're more curious about the item itself, since she talked also
Hmm.
a bit about the work that she does around this.
Hmm.
I think a good example, like for me, agentic AI, something that I've seen work up to now is either the Claude, which has a good performance rate, and
What is an agentic system?
yeah, they also have that option if you have the paid version. So I
Ah,
think ChatGPT and Gemini also now do that as well if you have the paid version of it.
I will never pay for well, okay, never say never, but I do not want to pay for an AI system. That just feels wrong. It feels like paying to like it feels like paying to like walk down the street or something. Feels like paying for water. Well, I guess you pay for
Yeah,
water in Europe. But that metaphor would make sense if we were, American based, because in America you never really have to pay for water.
I mean, I want to say you probably have already paid for some kind of form of AI, like agentic AI or any kind of form, since it has been around for a very long time.
Yeah.
but you just don't notice it because it's part of the
Yeah, I guess.
software itself, usually.
Okay, that's a good point. That's so scary.
And that's actually the interesting now because of the AI Act that's been implemented in Europe. Is that
Hmm.
companies and governments have to like actually start making lists actually what actually contains AI.
Well, yeah, like the transparency requirements.
Exactly. So that actually now you can actually look it up. If you Google it, you can look at because companies actually have to start saying, okay, what actually contains AI? I
Cool.
think.
Yeah. I was reading something the other day. I work a lot with GDPR and Article 22. Okay, well, this is gonna be difficult to remember off the top of my head, but like Article 22 involves a provision that's like constantly brought up with application to AI, and it's basically saying that like algorithmic decision making will not be permitted to have a legal effect. So if there's like a legal effect taking place, then the person upon whom the legal effect is being enacted on is entitled to a level of human review. But then I read a paper about how human review, specifically in the process of, or rather, I think the term is human in the loop, but human in the loop kind of production facilities are um like incapable of being effective in the modern age because AI is evolving so quickly and is so these like there are like black box models and you can't like interpret the contents of them, so like the human in the loop doesn't understand what's actually going on within the AI,
Mhm.
so then you can't get like full like actual explanation. It's this entire like long like tangent of reasoning. And on the concept of black box models and like understanding how operating systems or like LLMs or whatever arrive at their decisions, that's actually completely to do with like our third subject. But super briefly, just to wrap up our conversation on ethic AI, I did some I came across this like really cool. I don't know if it's a startup or if it's like a scale up now or like what type of form this takes. It could just be a research project, but it's called Agent Honeypot. So it's this program where basically to understand the extent to which agentic systems are being produced and deployed on the web, particularly in malicious formats, these people have like set up like an extremely like vulnerable like online platform, and then they're kind of just seeing how many they're trying to assess if any of the attacks on the platform are AI agents or
Mhm.
if they're actual people or if it's just AI. And you can just search up like LLM agent honeypot and it'll kind of give you like the stats on it. I think it was two confirmed AI agents have attacked it thus far. So that's two confirmed like malicious AI agent actors out there.
Mhm.
Obviously, potentially more, potentially none. Maybe their results are inaccurate, but it is like a really interesting real world like threat analysis scenario, especially when these things are so difficult to measure. And I kind of like that they're doing it in a way that's like, like preempting the
Mhm.
negative impact of agentic AI being developed. So, yeah.
I'm definitely gonna have a look at this because this actually sounds like a really interesting experiment that they're running. So
Mhm.
I'm actually gonna look into it.
Yeah, they also do like a really good explanation of like how they're operating the experiment. So like the ways in which they determine if it is an AI agent, AI actor or not. So number one, they do like prompt injections, and then
Mhm.
number two, it's targeted questions. And it's been a while since I have like actually read through it, so I can't like produce. I won't go into like a full description right now, but yeah, it's interesting. Check it out. And yeah, the general like catchphrase of the experiment is trying to have the ability to study algorithms in the wild and like assess risk and etc. So that's my opinions on AI agents. Hopefully they don't get any more risky.
Awesome. Well, thanks for sharing. So everyone, be definitely sure to check out LLM Agent Honeypot.
And update your passwords. I should actually probably do
You
that.
should do
Yeah.
that just in general every few
I know,
months.
I know, I know, I know, I know. That's like the irony of it. But yeah, update your passwords. Okay, so the next thing we're talking about, and the last thing is neuro-symbolic AI. So this one is also pretty complicated, and there's just like it's so dense, like there's so much to it. So referring again to that 1950s article, this time for the last time, Turing referenced a need for a punishment reward program that could be translated, understood, interpreted, yada yada, in a symbolic language. And I read through that entire paper. I think the word symbolic was only used once, or at least I only like identified it in like a relevant context once. And I saw the word symbolic and I was like, whoa, okay, because obviously that kind of relates to this discipline of AI research. So just like briefly breaking down the names. So neural obviously relates kind of to like neural networks, and then symbolic is um, kind of symbolic. So that's that. And neurosymbolic is essentially uniting two different camps on AI research development. That's basically how I understand that this kind of it was solidified as a discipline at a conference where people who won the Turing Prize were speaking. So that's cool, LinkedIn. And it was AAAI 2020 Turning Point. They basically said, let's integrate symbolic reasoning and deep learning and therein make neurosymbolic AI a more cohesive research community. Previously, there was a debate on symbols versus neurons, and it was kind of a more separated dynamic insofar as people were like, either like neural networks are better, or like symbolic dialogue, symbolic research is better, or just like kind of different paths. But this research, sorry, not research, well, I guess research conference, or rather AI conference, however, technology, whatever you want to put that, AAI 2020 Turning Point, all these really important people basically got together and were like, okay, like let's all hold hands, sing Kumbaya, and we will name it neurosymbolic. So that's great. Yeah. And neurosymbolic systems, you can kind of like read into how they arrive at decisions easier. So when I was talking about agentic systems, I was referencing black box models. So black box models are where you cannot read into or like understand the inner workings or deliberations of the kind of AI system. And neurosymbolic is different from that insofar as you're kind of able to get a greater insight into how the system is working.
Have you heard about neuro-symbolic?
The thing is, I had heard about it at conferences and stuff. People would mention it at conferences. Yeah, no, it is really like it's interesting how fast it's evolving and how many different like facets of thought that there are.
For me, it sounds like they're changing the way they're thinking. Okay, how should AI actually work when it comes to the reasoning thing? I feel like that's the switch in this technology. Or am I completely
Let's
wrong?
Oh my God. Like it's the blind leading the blind. No, just kidding. Um, so, I mean, all I understand it as is kind of a mechanism to enhance current AI systems and specifically make them more transparent in like the inner workings. So there's kind of two predominant systems. So A, B, system one, system two, unconscious. It also regards like pattern recognition. And then system two is slower, step by step, and then explicit. And this involves planning, deduction, and deliberative thinking. So neurosymbolic AI as a research discipline has identified these two different systems, and then there are different approaches for integrate. So it's kind of, okay, we have these like two concepts, how do we intertwine them? And a person who is really awarded, recognized for doing a lot of, like legwork in the realm of integration is Henry Kotz. And then he produced a taxonomy of neurosymbolic AI architectures. So different ways that you can combine those two aspects. Yeah.
Okay.
Feel like
No,
I'm ending a lot of
I think you definitely brought us all some more knowledge about this topic. Because yeah, like I said, I have never heard of it before. So for me, it's going to be reading papers on this
Yeah.
this weekend.
But another thing is that like we're like I work in the field, but the aspects that I work in, like the or at least like the current application, like specifically in Europe as well, because Europe is a completely different like scene.
Mhm.
It like this hasn't really come up before. I was doing different research into for my job currently into emerging different forms because I had to do like an EU AI Act application, and then that's when I like really started trying to read into it and understand it. But yeah, the material it's extremely dense. So I'll kind of just do like a little bit more of like what I know about it. So machines are really good at coming out with like yes or no, or coming out with like coming out with like logically deduced notions, but they struggle more with regards to abstraction. So neuro-symbolic AI is an attempt to kind of create that abstraction. And there's a reference in the research a lot to this notion. And, we kind of discussed this earlier with regards to AGI of creativity. Like, for example, something that was referenced as, a manifestation of neurosymbolic AI is DeepMind AlphaGo. I don't know if you saw this, but Google basically, it was like a few years ago, Google DeepMind created this AI system that was able to beat the world champion for a Chinese board game. And this was referenced in research articles as a good example of neurosymbolic or AI, or at least like the progression towards neuro-symbolic AI, and it's this deep learning system that was able to beat a world champion in AlphaGo, or in Go, which is a Chinese board game.
Mhm.
And there was a lot of numbers involved. But it was basically saying like this machine was able to perform this one in a million move, and it had to rely on creativity. And the world champion, upon being defeated, stated it is a creative machine. And that was like a really important metric in attempts to like enhance AI and, bring it out of just algorithmic functions and into an abstraction and creative realm. But there's also kind of the stipulation that I've seen in research that achieving this abstraction will enable infinite use of finite means. So basically, when we combine these two concepts, we will create something that is more than the means by which it was created, and it will allow for extrapolation, and kind of breaking down like how that extrapolation would be achieved. It would be computational discrete reasoning at a symbolic level, and the combination of learning and reasoning offers an important alternative to the problem of combinatorial reasoning by learning. So kind of like, my opinions, as if I haven't been already. I think that there's a lot of different contours and liminal spaces in this field of research, and as it becomes not more mainstream, because I suppose it is mainstream, but as it becomes more like, I don't know, heavily applied to society, or societally accessible, I think that there's going to be a lot more kind of deliberations on, I don't know, like what the symbols themselves mean and how we understand the symbols. I read a paper about Noam Chomsky and the concept of the language hierarchy, and how the language hierarchy and his, kind of deliberations would then be applied to symbolism. And I also read that proofs would be needed in the capability of different neural architectures to represent logical languages, and that would kind of be derived from Noam Chomsky and his work. So, and Noam Chomsky is, I mean, he's many things, like a philosopher, etc., but he's a linguist, so it is really compelling that you would require, or rather like think of the work of a linguist with regard to algorithms and machines and math. But that's what it's all about, I guess, is like kind of
Yeah.
combining
So
combining
we're pretty much going back to hieroglyphs. That's actually what you're saying.
God. I wish it was
It
that
was
easy
that,
to
yeah,
understand. Yeah. But anyway, my final thought, because I'm done with my thoughts after this, is everything that I've mentioned so far has shifting goalposts, and the field evolves so incredibly fast. Yeah. That's it for me.
Okay. No, for me also, so I'm basically getting, so neurosynthetic AI pretty much
Symbolic.
combines neural networks,
Symbolic.
which are
Neural
like
network.
learn from
Yeah, with
patterns
symbols.
from data, with symbolic AI, but also like uses logic and rules to create like smarter, more explainable systems that can both learn and reason, making AI more powerful.
Basically, differently. That is our podcast done, and we've discussed 3 different frontiers of AI development, and I hope you enjoyed listening.
Yeah. Thanks so much for joining us. Stay AI amazing, and we'll see you on the next episode.
Okay, bye.